Hello, welcome to our last tutorial of our From Sequences to Similarity series tutorials for Biopython. In this last one, we will build a phylogenetic tree starting from a list of 30 accession numbers with a corresponding country. We then will retrieve their sequences through Biopython. We will then do a cluster W, so that means there's a multiple sequence alignment. So this is an extension of the pairwise alignment that we discussed in the fourth tutorial. And then from this multi-sequence alignment, we will build a phylogenetic tree. But first of all, before you can run the code, you first have to unpack this cluster.zip file. So on Mac it's easy, I just have to double click it, and so we can start. So here, our fifth part, the phylogenetic tree construction. So you set the working directory, and then you obtain the sequences from this file. So have a look at this file. It's called accessions.txt. And in this file, you here have a sequence, so an accession number for sequence, and a country, separated by a comma. And now we return to our script. So first, we create an empty dictionary called FASTA file, and we put our count to 0. We open the accessions.txt file as a CSV file, and we read it using the CSV package. And then we extract the nucleotide sequences from Genbank using the accession numbers, which are the first element of each row of the CSV file. And then we parse each entrance, and then we will save the sequence in the FASTA file object. We can print the number of sequences in the file to check whether it's the same as the number of accession numbers that we imported. And then we will create the file sequences.txt, where we put the country as the description of the sequence and then the sequence itself. So, and you can find it here, sequences. So for Egypt, we have the sequence here, and you can scroll until the next FASTA symbol that we will see. From Ghana, you'll see, and now the sequence from Ghana is here. So this is a list of all accession numbers and countries in the file accessions.txt, because we printed it. And then finally, you see there are 30 countries, 30 sequences in the file. Okay, and so we do the multiple sequence alignment. So we use the command +omega command line from bio.align.applications, and we define our input file as sequence.txt, and the out file will be alignment COVID general.fasta. We construct the command by defining the input and the output file, and you will need, depending on your operating system, the correct chunk of code that you can choose. And then for Mac, uses this // and then the output of the cluster omega command line. And then we'll use this os.system input command to get that cluster program running and to do the MSA. This can take a while, but finally when it's ready, you will see it also when it's ready, then you will have this out file, this alignment _COVID _general.fasta in your working directory. So now we can draw the tree. We first of all need the output file from the MSA and import it using align.io. We also say this out file is a FASTA file. So we need a construct that indicates the similarity between all sequences, and that is something which we will do using the distance calculator. And so when we have this distance matrix, we can use UpGMA. It's a method to draw the phylogenetic tree, and we plot it using matplotlib. And so then we use this plot tree function to add some parameters to plot our tree. And so here we have this tree from these 30 sequences. And now, as you know, let's have a look here. Germany and USA WA2. So this is one of the two sequences from the COVID isolates from Washington, USA. So you see that it's very related to a COVID isolate from Germany. And because of these inners, which make a kind of distraction to this tree, we also put in the function this draw ASCII to construct this tree as well. It's not as nice as this one, of course, but it's much clearer. And so we leave it as an exercise for you. Can you make this tree without these inners? That's something to think about. So now we want to end this last tutorial with this phylogenetic tree. And this phylogenetic tree is also the last thing that is part of our Sequence to Similarity series of tutorials. We hope you all enjoyed them and that they are very useful for you. And if you have some extra remarks, you can always put them in the comment section. See you next time. Bye.